Example number 4, we want to prove that the limit of x squared as x approaches to 3 equal to 9. So this is the two-side limit. This will be L, f of x is x squared, and a is 3. So let epsilon greater than 0, then we can find a delta greater than 0 such that if we have the distance from x to a less than delta, then the distance from the function f of x to L less than epsilon. So a in this case is 3. So let's plug in 3 in here. So we notice that our goal is to get the x minus 3 to be up here, okay? Now let's factor this. So we have x plus 3 and x minus 3 less than epsilon. Then we want to get x minus 3. So we keep this and then we will divide both sides by the absolute value of x plus 3. You know that we will choose the delta, and the delta is depend on the epsilon only. Is in terms of the epsilon only. We don't want it to be in terms of the epsilon and the x. So we kind of want to make the x plus 3 to be a constant. Okay, so we're gonna choose delta to be 1. So if delta to be 1, then from this we have x minus 3 less than 1. And from algebra we can solve for x is negative 1 and 1 for x minus 3, and to add 3 both sides to get x by itself. So we have 2 and 4. And we want to have x plus 3 from this. So we will add 3 for all of them. So we get 7 and 5. So it's better for us to choose x plus 3 absolute value less than 7 so that it still stays symmetrical on the right side and left side to be the same, and it still stay in the bound of the absolute value. Then it's reasonable that we have x minus 3 less than epsilon divided by 7. So we would choose x plus 3 to be 7. Okay, then we will choose delta to be epsilon divided by 7. So the problem in this case is that we have 2 delta. So in step number 2, given that epsilon greater than 0, we will choose a delta to be the minimum. We have 2 choices of delta, so we have to choose the minimum of 1 and epsilon divided by 7. And you recall from example number 1 that if we have 2 choices of delta, we will choose the smaller delta, right? Smaller number. So that's the reason why we choose the minimum of the delta. Okay. Then if we have 0 less than the distance from x to 3 less than delta, we will have the distance from the function to 9 equal. And of course, this is what we want at the end is the epsilon, okay? So this step we verify that this works for the choice of the delta. So now we can factor. Okay, so we record that x plus 3 is less than 7. Absolute value of x plus 3 is less than 7. So I have 7. And then we have x minus 3 absolute value. We choose is less than epsilon divided by 7. So we can cancel out the 7 and we get epsilon. So we just proved that the limit of x squared is x approach to 3 equal to 9.